Mars and its Canals by Percival Lowell. Chapter 20. Next, to be caught of the details of this most curious network that meshes the surface of Mars was a set of phenomena stranger even than the lines, to wit, dark round dots standing at their intersections, more difficult to make out than the lines. They were, in consequence, detected thus later by 15 years. Once discovered, however, it became possible to trace their unconscious recognition back in time. Thus, Schiaparelli told the writer in 1895, apropos of those found at Flagstaff, that he had himself suspected them but could not make sure. Some of them stand figured in his Memoria Sesta, dealing with the opposition of 1888 but not published till 1899. In such posthumous recognition, as one may call it, the spots repeated the history of the canals. For Schiaparelli had himself pointed out a similar preconscious visioning of the canals in the delicate pencillings of Dawes and the streaks of Lockyer, Kaiser, and Secchi, now translatable as representing the Fison, the Euphrates, and half a dozen other canals imperfectly seen. That both the canals and the oasis were thus sketched before they were seen well enough to be definitely discovered is to an unprejudiced mind among their strongest credentials to credit. Nor was Schiaparelli the sole person thus to get proof before latter. One of their very earliest portrayals appears in a drawing by Otto Boedicker made on December 26, 1881, where the Sobas Lucas is clearly represented. In a still more imperfect manner, some of the spots had been adumbrated and their shadows drawn long before that. Thus, they may be deciphered as the cause of patches drawn by Dawes in 1864, though none of them were in any definite sense detected till 1879, and only then so ill-defined that their true character was not apparent. As patches, they are still commonly seen at observatories where the observational conditions are not of the best and the study of the planet not systematically enough pursued to have them disclose their true shape and size. The history of their detection is resumed in the experience of the individual observer. During the course of my own observations, I have had occasion to notice the several stages in recognition of the spots which have marked their chronologic career. As with the lines, 3 stages in the appearance of the spots may be remarked. First, where the scattering of the rays is so wide that dilution prevents anything from being seen. Second, where the commotion being less, the object appears as a grey patch. And third, where in comparative quiet, it condenses into a black dot. For the 2 former, our own air waves are to blame. In coursing waves of condensation and rarefaction, they spread the image of the spot as they do that of the canal. Then, as the currents calm, the spot shrinks to its normal proportions and, in so doing, darkens in consequence of being less widely diffused. Thus, the evolution in perception, which may take place in the course of an hour for a particular observer, represents exactly what has occurred in the person of the race by the improvement in observational methods and sights. That the spots, although wider than the canals, remained longer hidden from human sight is due to the optico-physic fact that a tenuous line may be perceived owing to its length when a dot of the same diameter would be invisible. Summation of impressions is undoubtedly the cause of this. The mere fact that a row of retinal cones is struck, although each be but feebly affected, is sufficient to raise the sum total into the sphere of consciousness. In the second stage of their visibility, the spots are in danger of mistake with the smaller true patches of somber hue which fleck the northern hemisphere of the planet and from which they differ totally in kind, totally so far as our present perception goes. Such true patches consist of a groundwork of shading upon which, indeed, are superposed the usual network of lines and spots. Prominent as instances of them are the Trivium charontis, the wedge of Cassius, and the mere Echidalium. With patches of the sort, the spots proper must not be confounded. Close treading on the heels of the detection of lines athwart the seas came the recognition of spots there likewise. At the opposition of 1896 to 1897, the number was added to, and so the tail has been steadily increased. Their number, as found at Flagstaff, up to the present time, that is, to the close of the opposition of 1905, is 186, of which 121 lie in the light regions, 42 in the dark areas of the southern hemisphere, and 23 in the smaller somber patches of the northern zones. From their relationships and behavior, it became apparent that the spots were not lakes, but something which answered much more nearly to oases. Of the spots, three kinds may be distinguished: the large, the little, and the less. If by the latter term it may be permitted to denote what has but collateral claim to be included and yet demands a certain recognition, for though not spots like the others, the members of the third class have certain traits in common with them, while differing radically in others. To the kind called large belong the greater number of spots so far found upon the disk. They are large only by comparison with the little, for they measure, according to my latest determinations, but 75 or 100 miles in diameter on the planet, some 2 degrees across. Sizable black pinheads. It is their tone that chiefly catches the eye, for they are commonly the darkest markings on the disk. Against the ochre stretches they appear black, and even in the midst of the dark areas they stand out almost as much contrasted with their surroundings as these do with the light regions themselves. About 140 are now known. Those in the light areas were discovered first, those in the dark regions being harder to see. Of this first kind are such spots as the Ciboas lucus, the Aquae calidi, the Lacus phonicis, and the Novum Via, or in English, the Grove of Ciboas, the Hot Springs, the Phoenix Lake, and the Nine Ways, to mention no more. That they bear dissimilar names implies no dissimilarity in structure. The phenomena are all remarkably alike and clearly betoken one and the same class of objects, differing between themselves at most in size and importance. In form, they all seem to be round. They certainly appear so, and were it not that retinal images of small areas tend to assume this shape, might implicitly be credited with being what they seem. The reason for optical circularity probably resides in the shape of the retinal cones and in their patterning into a mosaic floor, so that, unless a sufficient number of cones be struck, the images takes on to consciousness a roughly circular figure, whether it be so in fact or not. In the present case, however, they seem to be too well seen for self-deception of the sort. The little are distinguished from the large by being pinpoints instead of pinheads. They are most minute, from 15 to 25 miles in diameter only. That anything except size distinguishes the two apart is from their look improbable. In color, or rather tone, for distinctive color is of such minute objects unpredictable, they would seem to be alike. Such is also the case with their distribution and detail association. To the second class belong the Fons Juvante, Schiaparelli's Fountain of Youth, the Fons Immortalis in Elysium in 1905, and the Gygi Palace, besides many more. These are all pinpoints just upon the limit of vision, and noteworthy chiefly for being visible at all. all those detected so far lie not very distant from the equator, which may or may not be a matter of accident. It is not one of perception, since this part of the planet was not the best place for observation at the time they were discovered. To make out one of these little dots is a peculiarly pleasing bit of observation, as it requires particularly good definition. One might almost take them for fly specks upon the image did they not move with the disk. They have no perceptible size and yet are clearly larger in diameter than the canals which run into them, which proves how very slender the latter must be. Very early in the detection of the spots, it became evident that they were not scattered haphazard over the surface, but that, on the contrary, they were never found except at the meeting points of the lines. From this, it must not be supposed, as has been done, that the spots are merely optical reinforcements of the lines at their crossings due to the more crowded character there of the lines themselves, that they are not such as demonstrated by the existence of crossings where, either temporarily or permanently, none appear, which shows that they are far too well seen for any such illusion about them to be possible. At these crossings, the lines traverse one another without thickening, whether they be single or double lines. The spots, on the other hand, are much wider than the lines, giving a beaded look to the threads. In short, they are the knots to the canal network. All the more important junctions are characterized by their presence. Such starred junctions are not confined to the ochre regions. They dot the light and the dark areas with equal impartiality, thus showing themselves to be independent of the nature of the ground where large stretches of country are concerned. On the other hand, they appear to be unusually numerous in the smaller, isolated dark areas of the northern hemisphere, such as the Trivium, the Mare Achidalium, the Propontis, and the Wedge of Cassius. Here they crowd, and one cannot avoid the inference that their plentifulness in these regions is not due to chance. To the large spots, those of the first class, fall the places of intersection of the largest and most numerous canals, while the little spots make termini to fainter lines, ones that bear to them a like ratio of unimportance. Spots and lines are thus connected not simply in position but in size. The one is clearly dependent on the other, the importance of the center being gauged by the magnitude of its communications. From the fact of association, we now pass to the manner of it, which is quite as remarkable. The position of the spot relative to its tributary canals depends upon the character of the connecting lines. If the canal be single, it runs, so far as may be judged, straight into the middle of the oasis, or in other words, the oasis is symmetrically disposed about its end. This is true of the greater number of the large spots and of all the little ones, since the latter have as connections only single canals. In the case of a double canal arriving at a spot, a different and most curious dependence is observable. This fact I first noticed in a general way at the opposition of 1896 to 1897, the initial appearance of it being presented on September 30th, 1896, by the Kolopalus and the Phison. It was again visible in the case of the spots in the Trivium at the time the canals leading to that place doubled in March 1897, but the exact nature of the phenomenon was not fully appreciated till 1903, when the thing was seen so well as to appear cut on copper plate. It was this: the spot is exactly embraced between the two arms of the double canal. It is, moreover, seemingly perfectly round and just fits in between the parallel lines. The Ascreus Lucus was the first spot that showed thus in association with the double gigas. Others followed suit in so showing, several specimens presenting themselves so well as to leave no doubt of the precise connection. The sight presented by such a spot and its encasing double is a beautiful bit of detail, perhaps the most beautiful so far to be seen upon the Martian disk. The distinctness with which it stands out on occasion suggests a steel engraving and shows how clear cut the Martian features really are when our own air ceases from troubling and allows them to be at rest. Incidentally, we may note that this phenomenon alone serves to disprove the diplopic theory of the production of the double canals, for if a double were a single line seen out of focus, any spot upon it should be doubled too. It may seem to the reader as if what was seen in 1903 was but an unimportant advance over the observed phenomena of 1896 to 1897. Not so, however, for with the earlier instances it was not possible to be sure of the precise limits of the spot with regard to the double. The Colopalus, on the other hand, did not fill all the space apparently between the double Phison, while the Lucus Ismenius more than did so with the double Euphrates. To have set down the different appearances to insufficient definition would have been a great mistake, as subsequent observation has served to show. The Lucus Ismenius instances this. In 1896 to 1897, it was seen terminating the Euphrates, blocking all the space between the two lines and extending a little upon either side of them. Now, from its appearance in 1901, it was evident that the effect had been produced by twin spots lying along the deuteronilus, the axis joining them being perpendicular to the Euphrates. In 1903, the relation was still better explained by what appeared then, when not only did the two spots stand out, but the Euphrates showed with the line running centrally into each. Although originally seen by Schiaparelli as a single spot, and so at first seen by me, better acquaintance with the disk disclosed to both observers its really dual character. As this pair has persisted through all three of the most recent oppositions, it seems fairly certain that it is always of this character, and more fitting therefore to give it the plural appellative. This is the single instance of a double oasis. There are many that lie close together and might be taken as such, but this is the only one where the connection is intrinsic. According to measures of the drawings of 1905, extending through 6 presentations, the distance between the twin oases is 4°.2. Their relation to the canals which run into them is of the most complicated description and of the most suggestive character, for to the twin spots converge no less than 7 double canals, 1 wedge-shaped pair and 3 single canals, a most goodly number of communication lines. 4 of the double canals run into the oasis with 1 line to each. These canals are the Astaborus, the Narmalka, the Euphrates, and the Hiddekel. 3 doubles, the Protonilus, the Hehuan, and the Deuteronilus, embrace the oasis between their 2 lines, while in the singles the canal connects with one or other of the twins, as the case may be. Now there is method as to which of the doubles shall straddle, which embrace the 2 ismeni. Those which leave the place parallel or nearly so to the direction joining the Lucae enclose them both. Those of which the setting forth is at an angle to this direction depart, each line of the pair from the eastern and the western spot respectively. Consider now the disposition of these 7 pair of lines. All of them lie in one semicircle about the Lucae, beginning with the Protonilus on the east and ending with the Deuteronilus on the west. Furthermore, all follow approximately arcs of great circles except the Gihon, and all send one of their twin lines to one Lucus, one to the other. The data are enough to make this statement possible, although the west line of the Narmalka has not been caught entering its oasis. The east one has been seen to enter the other, and the width of the double shows that the west one must enter the corresponding spot. In the case of the Astaboras, the double has only been observed as far as the vexillum, but the south line has contained on to the west isthmius, and here again the width makes it certain that were the canal double throughout, the other line must enter the east isthmius. From the base line of the Proto-Deuteronilus, the inclinations of the 7 pairs are as follows. Protonilus 0 degree due east, Astaboras 40 degree north of east, Narmalka 70 degree north of east, Euphrates 80 degree north of west, Hiddekel 55 degree north of west, Gihon 0 degree north of west, Deuteronilus 0 degree due west. Now, the width between the two lines of the 4 canals to the east increases regularly from the Protonilus round, the Protonilus being the narrowest double, the Astaboras the next, the Narmalka the next, and the Euphrates the widest, and from the width between the twin oases that they severally enter the centers of them. What takes place in the case of the Hiddekel, which is wider than its tilt would imply, and in the Gihon, which is narrower, is not so clear, but that they enter the oasis in some place is certain. The spots make common termini for all the canals of a given neighborhood. In other words, canals converge to the places occupied by the spots and do not cross haphazard according to the laws of chance. Only one instance exists where a spot fails to gather to itself the whole sheaf of canals, and even there it collects all but 2. This anomaly is the Ciboas Lucas. The peculiarity of this oasis is that it lies not on, but just off, the Protonilus. That it does so is exceeding curious, considering that it is the sole example of such extra-canaline position. Strictly speaking, it is not the Protonilus but the point where the Protonilus turns into the Nilosartis, to which it stands thus neighboringly aloof, and this may explain the anomaly. For the Nilosartis has not the full geometric regularity of the normal canal and seems to have been a more or less fundamental feature of the region. For the rest, the Lucas has the form and possesses the canal connections appropriate to its state. It is apparently round and lies between the twin lines of the Phison and also between those of the Vexillum. Not far from the Ciboas Lucas are to be found all the examples of the third class of spots, for so far they have not been observed outside of area, a region peculiarly peopled by double canals. With double canals they are necessarily associated, inasmuch as they consist of shading in the form of a square or parallelogram, filling the deltas between 2 pairs that cross. Thus have shown the Colopalus at the crossing of the double Phison with the double Astaboras, and the Juturna Fons where the double Sitacus traverses the double Euphrates. At these same places a fourth kind is sometimes noticeable, a 4 square set of pinpoints or a 2 square set of the same at the corners of the line made parallelogram. This kind may well be synchronous with the third, though it has only been noticed at consecutive presentations. The third, however, has no observed dependence upon the first or second classes, and this serves to make more probable the true objectivity of the circular and the square figures respectively shown by each. The spots apparent in the dark regions do not appreciably differ in either size or shape from the bulk of those visible in the light. Equally with them they seem to be round, small, and nearly black. They would seem too, in the great diaphragm, or large contiguous sombre region, to be equally plentifully distributed. End of section 22. Recording by Surbhi Anand.